Hello everyone, this is Mr. McMillan, and in this example video we're going to be going over the example problems from page 3 on how to find missing side links using the Pythagorean theorem. And in our instructional video we already have went over numbers 13, 14, and 19. So in this video we will be going over the remaining ones on this page, 15 through 18 and 20 through 24. So number 15, we have B equals 5.9 feet and C equals 6.8 feet. So since we have B and C, we're going to be looking for A. And since we know that these triangles are right triangles, we know we're going to have to be using the Pythagorean theorem to solve for A. And remember that your Pythagorean theorem is A squared plus B squared equals C squared. We don't know what A squared is, so it just drops down. We do know that B is 5.9. And we do know that C is 6.8. Okay. Again, we can't do anything with the A squared, so we just drop it down. And 5.9 squared, get my calculator out here. 5.9 squared is 34.81. And 6.8 squared is 46.24. Okay. Now in this problem here, A squared and 34.81 are not like terms, and we want to get this A squared by itself. The only way to do that is by getting rid of this 34.81. And since we're adding it on this side to get rid of it, we do the opposite. So we need to subtract it. And what we do to one side, we have to do to the other. These 34.81s cancel, and we get A squared equals, and then here we get minus 34.81, which is 11.43. All right. Now, the key thing here is anytime you do any of these problems, you need to make sure that you are getting rid of whatever's with the variable. So normally we just would divide whatever the number in front of it is, right? But in this case, the squared is part of it, okay? So we need to figure out a way to cancel out the squared. And just like when we just subtracted 34 to get rid of this one, we need to do the opposite operation of a squared. And the opposite operation of a square is a square root. And again, what you do to one side, you do to the other. So the square root and the squared cancel on the left side. And so that leaves us with A equals the square root of 11.43. Now, obviously, the square root of 11.43 is probably not going to simplify. So we're just going to approximate it here. And then we're going to square root that, and we get approximately 3.38. Okay. All right, let's look at number 16. Number 16, we have A equal 2 meters and C equals root 13 meters. So we're looking for B. So that means we're looking for a leg. Remember, A and B are legs and C is the hypotenuse. So A squared plus B squared equals C squared. A squared is 2 squared plus, we don't know what B squared is, or B is. And C is the square root of 13, so we're going to put a parentheses root 13 squared. 2 squared is 4. B squared just drops down because we can't do anything with it. And remember, like we just said, a square is the opposite of a square root. So all this is going to do is cancel out and leave 13 behind. Well, B squared needs to be by itself on the left side, so we need to get rid of this 4, where it has a positive sign here. So to get rid of it, we need to subtract 4 from both sides. So this gives us B squared equals 9. We have to cancel out the squared. The opposite of a square is a square root. Square root both sides. This leaves you with b equals the square root of 9, which is 3. Now you might be going, well, hold on a second. Isn't the square root of 9 also negative 3? And that is true, but the only thing you can use here is the positive value because you can't have a negative side. All right, number 17, we have a equals 20 centimeters and b equals 21 centimeters. So we're looking for the hypotenuse c. So a squared plus b squared equals c squared. A squared is 20 squared. B squared is 21 squared. And c squared we do not know. 20 squared is 400. 21 squared is 441. And that's equal to c squared. Now we're just simplifying. We don't have to move anything over this time because the c squared is already by itself. We do need to combine the 400 and the 441, and that gives us 841. Then we need to cancel out the square, so we square root both sides. And I'm just going to make sure, I believe it's 29, but just to make sure, the square root of 841 is indeed 29. So that means that 29 is equal to c. In number 18, we have a equals 5 and c equals 13. So we're looking for b. So we have a squared plus b squared equals c squared. A squared is 5 squared. We don't know what b is. And c squared is 13 squared. 5 squared is 25. The b squared drops down. And 13 squared is 169. We need to get the b squared by itself on the left side, so we subtract 25 from both sides. And we get b squared equals 144. We have to get rid of the squared, so we square root both sides, and we get that b is equal to 12. All right. Now let's look at 20 through 24. Again, we already did this in number 19 in the example problems, in the example problems for the instructional video. So let's look at number 20. So this time, instead of being told what A, B, and C are, we're given a diagram, okay? And what you need to remember is that C is your hypotenuse, and A and B are your legs. Normally, I make A the short leg and B the long leg, okay? Now, your hypotenuse is always opposite of the right triangle or right angle. So in this case, we're going to be looking to see if we have a C value, and we see that the side opposite does have a value, which is 13.8, so that's our C value. Then as we can tell, the other two sides should be our legs. 4.1 would be A because it's our short leg, and X would be B because it's our long leg. And then we're going to set it up the exact same way. So A squared plus B squared equals C squared. We know A is 4.1 squared. We don't know what B is. Well, we know it's X, so we'll just put X squared here. And C is 13.8 squared. Now our calculator, 4.1 times 4.1 gives us 16.81. X squared drops down, and then 13.8 squared is 190.44. Okay. Now, we need to get the x squared by itself, so we're going to subtract 16.81 from both sides. We get x squared equals 173.63. Square root both sides to get rid of the squared, and you get that x equals approximately 13.18 inches. Okay. All right, so let's look at number 21. 21, we have a hypotenuse because the side opposite from the right angle is 15, so that's our C value. And then I'm going to label X as A, and 12 will be our B value. Okay. So we're going to solve for X, so A squared plus B squared equals C squared. So we have X squared plus 12 squared equals 15 squared. X squared drops down. 12 squared is 144, and 15 squared is 225. We have to get the x squared by itself, so we're going to subtract 144 from both sides. And you get that x squared equals 81. Square root both sides, and you get that x is equal to 9. Number 22. Number 22, we have numbers next to the sides that connect the right angle. So that means that we have both of our legs, but we do not have our hypotenuse. As you can tell, the side with x is opposite the right angle. So x would be our C value, 4 would be our B value, and 3 would be our A value. So A squared plus B squared equals C squared. A squared is 3 squared plus B squared is 4 squared, and then C squared is X squared. 3 squared is 9. 4 squared is 16. And we can't do anything with the x squared, so it just drops down. 9 plus 16 is 25, equal to x squared. We have to square root both sides to get rid of the squared. The square root of 25 gives us 5 for our x value. Number 23, again, it looks like we're missing our hypotenuse. The side opposite from the right angle has an x on it. So x is C, 6 is A, and 8 is B. A squared plus B squared equals C squared. A squared is 6 squared. B squared is 8 squared. And C squared is X squared. 6 squared is 36. 8 squared is 64, equal X squared. 36 plus 64 is 100, equal to x squared. We have to get rid of the squared, so we have to square root both sides because it's the opposite of a square. The square root of 100 gives us 10, and that just leaves 10 equal to x. And finally, the last one for this example video is number 24. Number 24, we see the side opposite from the right angle has a number, so C is is equal to 9. I'm going to put A as 6 and B as x. So we have A squared plus B squared equals C squared. So we're looking for B, which is our leg. A squared is 6 squared. B squared just is x squared, and C squared is 9 squared. 6 squared is 36. The x squared drops. And 9 squared is 81. Then we're going to subtract 36 from both sides to get the x squared by itself. So that gives us x squared equals 45. And now we have to take the square root of both sides. And so we get x is equal to square root of 45. Now, if you put that in a decimal notation, it won't sit in exact. So this is approximately 6.71. If you want it in exact, it's equal to 3 root 5. So that would be an answer. That would be the answer you would see on a quiz or a test. So 5 times 3. And you can see that it gives us the exact same thing there. Okay. So just letting you know, what you would do there is you would just, if root 45 isn't on there, you would just test each one of your ones to see which decimal would match up. Okay. And that's it for this video, guys. In the next video will be the instructional video for the converse of the Pythagorean theorem, which is where we determine, in addition to whether something is a right triangle or not, we determine whether it's acute or obtuse as well. So I hope this video has helped. If you have any questions, please let me know. Thanks, guys, and I will see you in the next video.